Welcome to this session. In this session, we start discussing about trigonometric integrals. So we start by discussing on how to integrate integrals of the form sine raised power mx cos raised power nx. So these are the kind of integrals that we are going to discuss in this session. So if you are given an integral of this form, sine of x raised power m cos of x raised power n, how do you go about it? So there are two cases to consider when you have such kind of integrals. So let's write the cases and then we'll do a problem to illustrate. So case one is when m can be written in the form 2k plus 1. And we know from our algebra that if we can write a number in the form 2k plus 1, where k is an integer, then that number is always an odd number. So we are considering the case whereby this power of sine is an odd number. So if we have that case, this is what you're supposed to do. Write sine raised power 2k plus 1x as 1 minus cos squared x multiplied by raised power k and then multiplied by sine x. You remember the identity that cos squared x plus sine squared x is 1. So sine squared x is the same as 1 minus cos squared x. I remember when you say from loss of indices, if you have a number a raised power 2k plus 1 is the same as a raised power 2k times a raised power 1. So, and a raised power 2k is the same as a raised power 2 and then raised power k, and then you multiply by a. So where our a for this case is sine. So sine can as well be written as 1 minus cos squared. So this defines sine. And then use this is square and then raised power k times sine x. Then the integral of sine raised power 2k plus 1 of x, and then cos n x dx becomes, remember 2k plus 1 is the value of m, integral of sine of x into 1 minus cos squared x raised power k times cosine raised power n of x dx. And then you substitute u equals to cos of x, which means that negative du is the same as sine x dx. So this part and this part will now be brought together, then they will be interpreted as negative du. And therefore the integral or the integrand will change purely in terms of cosines, and then where their cosines will be replaced by u. So we then use power rule to evaluate that. We'll see a specific example on that. And then case two, is when n is of the form 2k plus 1. That means that n is odd, the power of cosine is odd. So we write cos raised power 2k plus 1 x, and then write it as 1 minus sine squared x raised power k, and then you multiply by cosine of x. We're just still using the laws of indices. And because this is same as cos squared, and then so a power 2k plus 1 is a power 2k times a power 1, which is the same as a squared raised power k times a. So where a is a cost function. So that's what you are writing here. Then the integral sine power m x cos power n x dx becomes integral of sine power m x, and then where we have this, we write 1 minus sine squared x power k, and then multiplied by cosine of x dx, and then substitute u for sine x, which implies that the u will take the place of cos of x and then dx. So this part will be taken by u, and so where the sine you put u, and therefore this will just be a normal power rule problem. And then case 3, so I've considered a case whereby either the power of sine is odd or the power of cosine is odd. Now, case 3 is when both m and n are even. So there's also a case whereby none of them is odd, which means that all of them are even numbers. So for that case, we use the identities sine squared x equals to a half into 1 minus cos 2x sine squared x, cos squared x cos squared x equals to a half into 1 plus cos 2x, and then to rewrite the expressions into integrable forms by substitution method. So we'll describe that in a specific example in the next session. Thank you.